Now let's discuss the first partial exam. Let's see. The first problem, we're looking for the remainder by the syntactic division. What's going on? Oh, okay. So the function, polynomial function is fx equal to x to fourth power plus x squared minus 2x and plus 2 divided by gx equal to x plus 2. For the syntactic division, we have to realize we actually write g of x as x minus negative 2. So syntactic division is the following. Be careful, this f misses a term x cubed. So when you write them, you have to insert this 0. Some of you did not insert 0, get the wrong answer. And the negative 2 here. And leave one row blank. And you copy this number 1 down, and number 1 times negative 2, you put it here. And 0 plus negative 2 is negative 2. And negative 2 times negative 2 is 4. 1 plus 4 is 5. Negative 2 times 5 is negative 10. Negative 2 plus negative 10, negative 12. Negative 2 times negative 12 is 24. So 2 plus 24 is 26. So this is the remainder. The remainder is 26, not equal to 0. So gx is not a factor of fx. Okay, so it's not a factor fx. That's it. Second problem, we are looking for bounds to the real zeros of a fx polynomial. It is negative 6x to fourth power minus 3x cubed minus 7x squared and minus 6 and plus 1. Okay, 14, not plus 1, plus 14. So we factor the negative 6. It becomes plus 1/2 x cubed plus 7 over 6 x squared and plus x and minus 14 over 6. Right? You just divide all the coefficients by 6. Okay, so we check two numbers. One is max 1, and the other one will be absolute value of 1/2 plus absolute value of 7 over 6 plus 1 plus absolute value of negative 14 over 6. All right, so 1/2 is 3 over 6 plus 7 over 6 is 10 over 6 plus 14 over 6 is 24 over 6. 24 over 6 is 5. Is 4 plus 1 is 5. So the first max number is 5, and second max number is 1 plus max. We're going to get 1/2, 7 over 6, 1, and 14 over 6. Be careful, in those computation, all the coefficients will be put ups value, so it's always positive number. You compare those four numbers, you get 14 over 6 is a maximum value. So it's 20 over 6. Be careful. This, you cannot write this way. You cannot write this way. I understand what you mean. You mean you're going to divide the top and bottom by 2, but it's not written this way, okay? So you divide, or you cancel 2 from top and bottom, you get 3 over 10. You cancel 2, this is wrong. This is wrong. You artificially divide a fraction by number 2, it's not 10 over 3. You cancel 2 from top and bottom, you get 10 over 3. And you compare 5 and 10 over 3, you you can get a bound by the theorem. By the bound theorem, we can choose a bound m be the minimum number, smaller number among these two values. So 10 over 3 is definitely smaller than 5. 5 is 15 over 3, right? So this is the answer. Okay, so problem 2. And problem 3, we are going to use the rational zero theorem to find all real zeros of a polynomial. Fx is equal to 2x cubed plus 7x squared plus 2x minus 3. So if x is p over q, then definitely you get p divides -3 and q divides number 2. So p could be plus minus 1 plus minus 3, and q could be plus minus 1 plus minus 2. So we have potential rational zeros are what? Plus minus 1, plus minus 3, plus minus 1/2, plus minus 3/2. All right, so we have 8 possibilities. So what do? We are going to check f of 1, see what it is. So it's a 2, 7, 2 minus 3 is 8. So 1 is not 0. Then we check f of -1. We will get a -2, positive 7, and -2 minus 3. Okay, this time it's 0. So we know -1 is a 0 of fx. This also implies x minus -1, which is x plus 1, is a factor of fx. Okay, so you can use several ways. So here we already try the syntactic division. Let's try other divisions. So I'm going to use the long division to find the other factor. Okay, so let's check here. This is a 2x cubed plus 7x squared plus 2x minus 3 divided by x plus 1. You divide 2x cubed by x, you get 2x squared. And then 2x squared times x is 2x cubed. 2x squared times 1 is 2x squared. You do subtractions of 5x squared plus 2x. And then you divide 5x squared by x, you get 5x. It's 5x squared plus 5x. And it's -3x minus 3. And then you divide -3x by x minus 3. 0. So we get fx equal to x plus 1 times 2x plus 5 and minus 3. Okay? Now we have a quadratic equation. We know how to find the zeros of a quadratic equation. We can factor it by the cross multiplication. So 2 is factored as 2 times 1. -3 is factored as -1 times 3. 2 times 3 is 6. 1 times -1 is -1. The sum is 5. This 5 is exactly this coefficient 5, including the sign, it's positive 5. So you put x here and x here. I just copy. And this one is 2x minus 1. X plus 3. So -1, 1/2, and -3 are zeros. Okay, so that's it. That's all solutions. Of course, you can try f. Here you try f1, f-1. You can try f3, f-3, f1/2, f-1/2, f3/2, f-3/2. You can try them. But I think it will you will have a long computation. But anyway, that's correct. If you get the right answer, that is correct. Problem 4, we are going to apply IVT intermediate value theorem. Fx is negative 3x to 4th power plus 4x cubed and minus 8x and plus 2. So in order to apply the intermediate value theorem, you need a point so that the function evaluated at that point is positive. At another point, the evaluation is negative. They have different sign. Then you can claim by the IVT there is a 0 between them. Okay? So of course, I saw some of you try 1, 0, 10, and some of you even try 2. Well, 2 is also very simple, but I prefer either we choose 0, or we choose 1, or we choose 10. They're even the faster. So I check F0. I always check F0 first because it's simple. This is 0, 0, 0. So F0 is 2. So now I have a point with a positive evaluation. I need a point with negative evaluation. You see, x to 4th power is a positive, but times negative 3, it is going to be negative. So I'm going to check 10. I'm check 10 and check 10. It's a negative 3. 10 to 4th power, 1, 2, 3, 4. 10 to 4th power, you get 4, 0. 10 cubed, you get 3, 0. 10, 8, 8 plus 2. Yes. Well, this is a 4002 minus minus 80. It's a plus 3922. 3922. Yes. And then you do subtraction. It's going to be well, I even don't care what the value it is, but here the negative 30,000. This is just the 3,900 is negative. Okay? At the 0 is positive, at 10 is negative. Then by IVT, Fx has a 0 between 0 and 10. I saw some of you, at least 2 or 3 of you, just find 2 numbers and evaluate. One is positive, one is negative, and then they stop. They didn't claim anything, just find one positive value, one negative value, and that's it. That is incomplete, and you definitely lose points because you didn't finish it. What do you mean you get a positive evaluation, negative evaluation? What is the usage of them? Right? You cannot just, the purpose is not to find a positive value, a negative value. The purpose is to find a 0. Okay? All right. So you must write the last conclusion by the IVT. Fx has a 0 between 0 and 10. That's the purpose. We're trying to find the zeros. 5, we're going to solve the system of equations. X plus 2y plus 2z is equal to 1. 2x plus 2y plus z is equal to 1. And 3x plus y plus 2z is equal to 1. All right, so you can use the matrices, or you can just directly use cancellation. For example, let's try the cancellation. Let's call them equation 1, equation 2, equation 3. We use equation 1 to subtract equation 2. I want to cancel y because here's 2y, here's 2y. So equation 1 minus equation 2, x minus 2x, negative x. 2y minus 2y is 0. 2z minus z, 1 minus 1, 0. Okay, so that's equation 4. And then I'm going to combine equation 1 and equation 3. But this time, I still want to cancel y. So I'm going to, but here it's a y, not 2y. So 2 times equation 3. I want to cancel this. 1. Here, 2 times it is 6. 1 minus 1, x minus 6x is negative 5x. 2y minus 2y is 0. 2z here. Remember, this is 2 times 2z. It's a 4z. 2z minus 4z minus 2z. 1 minus 2, negative 1. Right? So just be careful here. You have to multiply all the numbers by number 2 and then do the corresponding subtraction. Be careful. In this part, we cancel negative sign. We multiply two sides by negative 1. We'll get a positive 1. I like this better. And from here, we can see that negative x plus z is equal to 0. So from equation 4, we know x is equal to z. And then plug in to 5. So 5x plus 2x is equal to 1. So x is a 1 over 7. And of course, it's z. All right, so x equal to z equal to 1 over 7. And then you put it here in the first equation, 1 over 7 plus 2y plus 2z. 2z is 2 over 7 is a 1. So it's a 3 over 7. So 2y is equal to 4 over 7. 4 over 7 is, comes from 1 minus 3 over 7. So y is a 2 over 7. So the solution is 1 over 7, 2 over 7, and 1 over 7. Remember, this is ordered triple. So it's x, y, and z. Okay. Problem 6. Problem 6, we find the inverse function of a y equal to negative 3e to negative 2x. All right, so first interchange x and y. Solve for y in terms of x, divided by negative 3. We apply the natural log. This is by definition. Remember what is b is e to a, then log b is equal to a. Right? And then divide by negative 2. That's it. So the inverse function, f inverse of x, is just negative 1/2 log negative x over 3. That's the answer. Problem 7. Problem 7, we're trying to practice the property of a logarithmic function. So natural log, a very complex expression. 5x squared. Oh, not x squared, x cubed. Sorry. Let me make my page bigger. I can read. 5x cubed, the fifth root of 1 plus x over 4 times x minus 1 squared. The whole thing to square. So you apply square first and then logarithmic function. Okay, so now what do? We move this number 2 forward. We have a log. Log a over b is log a minus log b. Log a over b is like this. All right? So log ab here is log 5 log x cubed. Log fifth root is power 1 over 5 minus log 4 log x minus 1 squared. And we continue the simplification, so we are going to distribute this number 2 into it. So 2 log 5, move this 3 forward is the 3 times 2 is a 6 log x. 2 times this is 1 over 5. 2/5 log 1 plus x minus 2 log 4. And again, be careful, it's also minus 4. Here's 2, here's 2. 4 log x minus 1. This is the answer. This answer. Problem 8, we're going to compute the determinant. Let me copy it first. And this determinant, because this position is 0, so in fact, I want you to expand this 3 by 3 determinant either along the second row or second column. But it doesn't matter. Many of you expanded along the first row. It's okay. So it's 1 times 1 times this. Yeah. So it's 0, -5, -2, 9 minus minus what? This is 2. Okay, minus 2, 2, 4, -5, and 9. And plus, here's -6, 2, 0, 4, -2. Okay, so it's a plus minus plus. That's along the first row. If you expand it along second row, it will be minus plus minus. Remember that. It's a plus here. Plus starts from the top left corner. Plus minus plus. Plus minus plus. Minus plus minus. Be careful. All right, so 1 times everything is just it. So 0 times 9, 0. Minus -5 times -2 is 10, minus 10. 2 times 9 is 18, minus 4 times -5, -20. Minus 6 times 2 times -2, -4, minus 0. Okay? So here is 18 plus 20 is 38. 38 times 2 is 38, 76, right? 38, 76. Okay, let's assume I'm right. 24. 6 times 4 is 24 plus. So it's 86, -86 plus 24 is -62. Yes, that's the right answer. So the answer should be -62. Okay. Next. Oh, next is interesting. Next, problem 9. Given that 7 to the power -2x is equal to 3, we're looking for 7 to the power 6x minus 2. So most of you know the part of the computation, right? So 7 to 6x times 7 to -2. And 7 to -2 is 1 over 7 squared. 7 to 6x, because we have 7 to -2x, so you're going to have 7 to -2x, and then -3. -3 times -2x is 6x. Okay? So here you get 1 over 49. This place, you're going to put 3 -3. 3 -3 is 1 over 3 cubed. 3 cubed is what? 3 times 3, 9, 9 times 3, 27. And then you're going to have 1 over 49 times 1 over 27. 1 over 49 times 1 over 27 is 1 over 1,323. So the correct answer should be this. All right. So problem 10. We have a function f(x) equal to x to 4th power minus 2x cubed plus kx squared and plus 1. It has a factor x minus 2. It's very good. It's already subtraction, so this is number c. C is equal to 2. A polynomial has a factor x minus c, so fc should be 0. C is 2. So we get f of 2, which is 2 to 4th power 16, minus 2 cubed is 3 times 2k is 16k. 2 squared is 4 plus 4k and plus 1. It must be 0. Okay, so this is 16 plus 1, 17. Negative 16 plus 4, 16k, negative 16k plus 4k is minus 12k is 0. So 12k is 17. So k is 17 over 12. 17 over 12. This is the right answer. Okay. Problem 11. Problem 11. I'm not going to sketch the graph. We see that we have a point negative 2, negative 2. We have a point 0, negative 1. We have a point 1, 0. And we have a point 2, 1 half. We're looking for f negative 2. This is the point on the graph of f. So f negative 2, you're checking this value. It's negative 2. f2, you're reading this value. It's 1 half. f inverse of 0. F inverse 0, you start from y. So this is 0. The value is 1. And f inverse of negative 2. See, this is 1 half. This is 0, negative 1, negative. Negative 2 is here. The counterpart is negative 2. So these are the answers. Okay, so 11 is okay. 12 is not too bad. So 4 to x times 2 to x squared is equal to 16 squared. And 4 to x, if you write it, it becomes 2x times 2 to x squared is equal to 16 is 2 to 4. And then squared is 2 to 8. So most of you, almost all of you, get this equation correctly. So 2x plus x squared is equal to 8. So x squared plus 2x minus 8 is equal to 0. X plus 4x minus 2 is equal to 0. So x is negative 4, or x is equal to 2. They are the solution, and that's it. All right, so I finished the discussion about this first partial exam, and you can check it with your answers. If you have any questions or doubts, let me know. I'm happy to discuss it. Okay, thank you.